Saxon Algebra 1/2, lesson 89. I told you this lesson was coming a while back. John calls it value problems, but I would call this lesson coin-ish problems. Do you remember when we learned coin problems and I told you that we were going to take kind of the basic structure of those two equations that we create and the way we set them up, and that we would apply it to some other scenarios? Well, this is that lesson. They are not problems technically about coins, but they are ish. It's a similar structure. And you remember that the whole jam with the coin problems is first we write a equation about the quantity, the number of things that we have, and then we multiply it. We multiply the quantity numbers by the value, what they're worth, right? So we're going to follow the same pattern of quantity and volume in our new ones. Let's look. Oh my gosh, I'm so excited to find out what that first story is. Airline fares, prepare to laugh, by the way. Airline fares for flights from Tifton to Adele, I don't know where that is, Tifton to Adele are, ready? $30 for first class and $25 for tourist. I mean, don't you wish? If a flight had 52 passengers, that's not very many, who paid a total of that many dollars, 1,360, how many first class passengers were on the trip? Okay, so what we can see is that the passengers are like the coins, right? We have a certain number of passengers, but passengers have to pay a certain amount depending on whether they want a first class or a tourist seat. So tourist is like coach. So the passengers are like the coins, and the values that they represent are driven by the ticket prices. Does that kind of make sense? You can sort of see the parallels there. Okay, so what we're going to do is, instead of using like number of nickels and number of dimes and number of quarters, we're going to say the number of tourist class passengers plus the number of first class passengers equals, it said the flight had 52 passengers. So the number of tourist flyers plus the number of first classers has to equal 52. Now we'll multiply each of these by the ticket price. And that will tell us how much money the airline collected for the entire flight, which John told us. Okay, he told us the amount of the prices. He said oh, I'm looking at the wrong problem. No wonder the numbers confuse me. $30 for first class and $25 for tourist. Okay, so I wrote tourist first. So $25 times the number of tourists plus $30 times the number of first class. I would really love to pay $30 to ride first class. Equals 1,360. That's dollars. These are also dollars. Remember in the other coin problems when we had that drama because we wrote the amount of the coins, like 25 for a quarter, but then we had to convert the money from dollars into cents. Remember how there was that little bit of drama? We don't have that drama anymore. Everything's just in dollars, so we're fine. All right, there we are. One time I went to India to teach some cute little orphan girls to read and did art projects with them for a couple weeks. And when I was coming back, it was a part of India where they don't get much tourism. It's a city called Hyderabad. It's like right in the middle of India. It's a big city, but it's not necessarily super touristy. So they don't get a lot of white ladies there, I'll be honest. And when I was coming back, the ticket agent in the airport in Hyderabad was like, he held me up and he was doing some things that I was very confused about. And I didn't understand what was going on. And I was a little paranoid because India's a crazy place. And I was by myself at this point. But in the end, what he was doing was he was upgrading me to have a really nice seat. It was an international flight. We were flying from Hyderabad to Dubai. And he gave me the kind where your chair folds into a bed and you have all the special compartments and nice slippers and everything. And normally I just fly the cheapest flight I can get, right? I don't care. I just sleep in my seat and it'll all be over soon. But I had such a bougie accommodation on that flight. It was heaven. I laid down and slept like a baby in my little sleeper bed on the plane. So I only wish I could get that for $30. All right, now I'm done with my side story. How are we going to solve this equation? Well, here is the glory of it, you guys. At this point in your algebra careers, John says, hey, look, you know how to eliminate, you know how to substitute. Do whatever you like. You can do it however you want to do it, and it'll just be fine. So what I recommend that you do is mix it up, because you probably prefer one over the other at this point, but I want you to feel equally comfortable with both of them, because there will be problems when we have to go with one or the other. So I want you to be like, yeah, no problem, I can do it. In this one, because I see these two variables that have no coefficient, I'm going to rearrange and I'm going to substitute. So I'm going to keep the NT here. I'm going to kick the NF to the other side. So that will become NT equals 52 minus NF, right? I just clunked that over. I'm going to gently scribble that out. And then I'm going to substitute that in right there. I'm going to have to multiply 52 times 25, but I mean, it'll be okay, right? So here I substituted in 25. Instead of NT, I put this in 52 minus NF plus 30 NF equals 1360. Now, I'll do my multiplication over here, 52, 25. It's going to be a lot of tens, isn't it? 25, 26. 2 times 2 is 4. There's the 0. 5 times 2 is 10. 0, 0. 1,300. Okay, I kind of like that, because it's going to be super easy to subtract. Minus 25 and F, right? Don't forget to distribute to both. That's a perpetual, that's just a problem. It's a trap is what it is. Let's be honest. 1360. Now, in one step, I'm going to combine those like terms, and then I'm going to subtract. I'm going to swim this number fish over here. And what we're going to get, goodbye, these two give me a 5 and F, and these two give me a 60. Are you with me? So far, so good, right? It looks pretty reasonable. And we divide by 5, and we get the number of first-class passengers equals 12. All right, 60 goes into, 5 goes into 60 12 times. All right, and then we know that the number of tourists is 52 minus this. So the number of tourists must be 40. And just to double check, there's my 52 that they're supposed to add up to. All right, so this is my answer. This is the best way to show it. You don't have to write any words because these variables basically represent words. This is correct. Oh my gosh, how do you feel about it? Fun, right? Now, if you are doing these problems in your homework and you do not feel super confident about the solving part of it, then what I recommend that you do is look, like in this example, look and see how does John do it. You would look in the solutions manual, but my examples are right here in the book. And I see, oh, I see what John is doing. He chose to eliminate. We will solve these equations by eliminating. We'll multiply a by minus 30. Ah, okay, so he canceled there. You can choose to do it John's way just in these first few lessons where we're doing these problems, just to help you use the rest of his problem for guidance. Because if you choose a different method than what he shows you in the solutions manual, is not going to be any help. So if you feel like you want that a little training wheels on your problem, then go ahead and peek at the solution and see what strategy he chose, and then follow the same strategy so the solutions manual will help you. If you feel confident, do whatever you want. That's the way this works. Okay, that's 89.1. Let's start 89.2 right here. And the hardest part of this is just setting up the equations. Solving it should not challenge you too much. Okay, ready? Here comes another great story. I love the stories John cooks up for these. Wataksha's dress shop. I think she's Russian. Wataksha. Wataksha's dress shop sold less expensive dresses for $20 each and more expensive dresses for $45 each. That sounds like fast fashion to me. The shop took in $1,375 and sold 20 more of the less expensive dresses than it did the more expensive dresses. How many of each kind did they sell? This reminds me of my birthday when I was maybe 8 or 9 and I got a Barbie fashion shop. It was like a dress store for my Barbies. So this is just channeling that all back. All right, so we have the number of less expensive dresses plus the number of more expensive dresses. I'm writing a quantity statement here. It says, it doesn't tell us how many they sold in all, but it tells me that they sold more of the less expensive dresses. Okay, so there's the number of less expensive dresses sold was greater than the number of more expensive dresses sold. The number that balances is 20. So I'm going to add 20 to this side, and now they're equal. Okay? This one has a little bit more challenging quantity equation than this first one. This first one was pretty easy. It just said the total was 52. Here, they don't tell us the total, but they tell us something about the balancing number between them. They sold more of the less expensive. They sold 20 more of the less expensive than they did the more expensive. So that one we have to think a little harder, and that's kind of tricky. I'll be the first to admit it. All right. And now we're going to take into account the value of them. The less expensive dresses cost $20. And the more expensive are $45. I think they got them at H&M. Or maybe even Forever 21. But when they sold the less expensive dresses at $20 and the more expensive at $45, the total was 1,375 doll hairs. All right, guess what? We now have a system of equations. And we're all set up to substitute again, right? Because we have the number of less expensive all by itself. So let's go ahead and substitute again. I see no reason to make this harder than it is. So 20, and we'll put this in place of NL. NM plus 20. There's two 20s in here. They're not the same, right? They're two different numbers that just happen to be the same. Plus 45 equals 1375. Okay, ready? 20 NM plus 400 plus 45 NM equals that same number, right? I'm just distributing. Now let's combine the two NMs and we'll subtract the 400 at the same time. And what we get is, I'm getting down to the bottom of my page, 65 NM, right? The 20 and the 45. This cancels, equals 975. All right. Do you suppose that 65 goes into 975 evenly, I should say? I've got hope. Let me find my little book. Little book. It's hiding from me. I have, that small, I have a cart, a rolly cart that I keep all my math books in. But you know what? It's just eluding me right now. So here's what we're going to do, you guys. We're just going to jump into the Algebra 2 book and use a piece of their paper. Ready? We'll just go to the middle because I don't want to recopy this to the next page. Okay, so what we've got is this. We're dividing both sides by 65. 975 divided by 65. I'm just going to leave this problem in there, and someday when I'm doing a video for the red class, they'll be like, wait, what is this? That's going to go in here once, right? 1 times 65 is that. I subtract 325. I'm going to guess it's 5. The reason I'm guessing 5 is because 5 times 5 is 25, and that would give me a 5 right there, right? Oh, and look, 5 times 6 is 30, plus 2 more is 32. That's right. So 15 is our answer. Thank you, book. You provided a good service to us. So the number of more expensive dresses was, what did I say? 15. And the number of less expensive, we add 20 to that. So the number of less expensive is 45. That should be our answer right there. Oh, I added 20 wrong. See how easy it is to make a knuckle-headed mistake? This should be 35. It really does always help to show your work, because if I would have turned this in, I would have just not been able to give myself points for 45 because it was a ridiculous answer and I didn't show my work anywhere. But let that be a lesson to you, my students. Okay, that is the end of this lesson, our coin-ish problems. I hope you can see how they just work just like a coin problem, only we have to think, we have to think a little harder, don't we? That's the thing about John, he's always pushing us onward and upward to mathematical superiority. Okay, I don't know what I'm talking about. I'm going to go now. Goodbye.